So this is a question of optimized water distribution. Okay. So what do you mean by the question? So I'm just going to explain in the question in the open board so you understand what I'm going to see, what I'm going to say you. Okay. So the question is optimized water distribution. Okay. So there are we provide some nodes where the pipelines is connected like this. We take 1, 2, 3, 4, 5 like this. Okay. So this is our pipelines. This is our pipeline. Okay. This is our pipelines and this is our nodes. This is our place. This is our nodes, or you can say anything. This is our place where we have to map it. Like we have to connect the all places. This is our pipeline. You have to say that the weight of this pipeline is 5. You have to say the weight of this pipeline is 7, 6. You have to say the weight of this line is 7. You can take the weight of this line is 8, 10, 11. Okay. So what we have to do? We have to connect the all pipelines. We have to connect the all pipelines with these nodes, with these places in a minimum weight. In a minimum weight. Minimum weight means we have to minimum cost or weight. You can say anything. So how we can connect the all nodes? How we can connect the all nodes? You find it that this is a question of graph. Okay. So we have to connect the all nodes in a minimum base. Okay, like this. If you find out that how we can connect this, how we can connect that everything is connected with a minimum cost. Like the principle, the minimum span tree. Okay. So what is minimum span tree? In a minimum span tree, we find a permutation of all vertex. What I want to say you like this. 0, 1. If this is a graph, like 1 second. Okay, so if we have a graph like this, 0 to 1, 2, 3, and 5, and 6, and these 4. Okay, and the weight of this is 11, 10, 10, 2. So we have to reach here. So we have to connect all vertices. We have to connect all vertices. In minimum spanning tree, we have to connect all vertices. Like how many vertices we have? 0, 1, 2. 0, 1, 2, 3, 4, 5, 6. So we have to connect all vertices with minimum edge sum. With minimum edge sum, it means when we go in this direction, then we can't take this direction. We have to take this because there are a minimum edge weight. Because the weight is here is 10. Okay. After that we can't. We have to move here because the weight is minimum, and after that we have to move here because weight is minimum. So we have to just connect the all dots, and we can't move again because we connect this 0 to 3. So our minimum spanning tree which is so our minimum spanning tree is this. Okay, why? Because this weight is minimum in this pattern. Okay, so we have same thing here. We have to apply same thing. We have to apply same thing. We have to connect all the pipelines using minimum weight. Here we take 10. We don't take 13. We can also take 13, but we don't take 13 because we can't. We does not want to connect with a minimum weight, with a maximum weight, because it takes a maximum, because it will go 6, then it will take a maximum weight because it can get the minimum weight here. Okay, so it move here and it move here and it move here. Okay, so minimum spanning is like a minimum weight, minimum cost. Okay, so what you have to do in this question, you have so this is a simple question. So but if something was changed in this question, the change is like this. You can create on wealth. 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 It means you can create on wealth. It means we can connect the all. We can connect the all nodes to single wealth. Wealth means where we supply the water. Where we supply the water to all vertex. Okay, what I'm saying to you, the another approach is like we can create his own owns. Own owns, it means where he can supply water. When he creates his own all owns, then he can supply the water. But and also we can supply the water by himself. But if he has a water, then it can supply then he can supply here, it can supply here. But what? We can supply the water using valve. Okay, this common valve. So how we can create a graph? You just understand what I'm saying to you. So we are going to create a graph. Okay, so how we can create the graph? So sorry. So If this is 1, this is 2, this is 3, this is 4, this is 5, okay, and it is connected with this, 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 okay. So we have to supply the water, we have to supply the water by these connections, by these edges, okay. But we have another approach, we have on wells, we have on wells, we have on wells, we have on wells. So how we can find out the which minimum, which spanning tree, which path, which type of place is good for supply the water, which type of path, like this 1 2 3 5 4 or 1 4 2 5 3, which type of path is valid for distributing the water, or distributing the water, which pattern is good, okay. So we are applying a minimum spanning tree formula, but we have a common wealth, so we create a common wealth, okay, and we connect the all, we connect the all nodes with this commonwealth, okay, we connect the all with, so now we figure out the formula, so now we figure out the formula, so now we have to find out the weight, okay. So now we find out the weight, okay. So we are going to find out the now we are going to find out the weight, which weight is maximum, okay. So now we are going to find out which weight is maximum, because we create a commonwealth for that everyone, okay. So now we have to create the which minimum spanning tree is good for this water distribution system, okay. So we are going to code it so you understand what I'm trying to use, okay. Now we are going to code it. So in this question, you understand the pipes, okay. In this question, what we have to do, you have to just find out something much extra like this, common zero, okay. So what do you mean by common zero? So here we have to take a pair. Why we take a pair? Because we have to store the pipes length, okay, like walls, like edges, v weight, everything is, so you have to create a pair class, okay. So in this, what we have to go, what you have to do, we create an array, like how many edges we have, okay. So first we create an array, that how many edges we have, okay. So we create a array of pair class, okay. Sorry, I think it's very smaller, so we have to just increase the font size, okay. So font size increased. So now we have to just increase the okay. So now we have to just put pair, we just create a pair. So now we have to just create a pair class of edge, and then new pair, where we store the all edges, where we store the all edges. So what we have to put a pipes dot length, okay, because we put the all pairs in this pipes dot length, okay. What I'm saying to you is that we store the all pipes, all edges, which can make the we make the connection between all nodes, all places for water distribution, okay. So now we take an index, we take index I equal to 0, okay, and then we take a for int int I equal to 0 and I less than pipes dot length I plus plus, and then we take all vertices. First we take int v, and this width, we have to two types of vertex now, one is v and one is u and his weight, okay. So we have to two types of vertex, like first and second. So we represent first with v and second represent with u. Sorry, we represent the first vertex with u and second with v. So first we represent the first with 0. Sorry, this is a 2D matrix where we find the first value, which is called u, okay. Int v equal to pipes I 1. Okay, and then we take int weight pipes I 2. Okay, so now what we are going to do, we have to just find out edges. Okay, so now what we have to do, we have to just put at in this array these all into a new pair. We create a pair of that all edges. Okay, we create the pair with all edges with her weight. Okay, so we just create a pair of u comma v comma weight. Okay, so only store in the edges, pair of edges. Okay, so now after that we increase the indexes. Okay, this indexes will tell us that how many edges we are is presented in this graph. Okay, so now after that what we have to do, we have to just put a wealth. So we have to put a common wealth. Okay, so all wealth is connected with this. So what we have to do, what I'm going to do is, we connected the all wealth. So in this folder we are going to connect it the all wealth with this common path, we connected the all nodes with this common wealth. Okay, for water distribution. So now we are going to connect the all vertices, walls, wealth with this this vertices with this so now what we are going to do, we have to just find the now we are going to do, we just create a pair with wealth with all nodes. Okay, and we store this pair in the edge. Okay, so what we are going to do, we just take a wealth. Okay, and we take u equal to 0, which tell us that initially our, what I'm saying to you understand, we just create this 0 with this 1, this 2, this 3, this is 4, this is 5. Okay, so what we're going to do, we create this 0 with this 1, this 2, we connect this 3 with this 4 with this 5. Okay, so we're taking initially I equal to 0 and connected with all 1, 2, 3, 4, 5. Okay, so this 0 will constant. Okay, for everyone. So after that we increase the v. Okay, because we have to connect the g1 na, so 0 plus 1. Okay, so we have to increase I plus 1. After that we take a weight. Okay, where we provide a walls and I, and then edges at index equal to new pair u comma v comma weight. Okay, and after that we put it here and idx plus plus. Okay, and after that, so this is our wealth. Okay, after that we increase the idx. Okay, so it will tell us that how many pairs we are forming. Okay, after that what we have to do, we have to just create a graph. So now we have to create a graph. Okay, so now we have to create a graph. Okay, so in this graph we take array list and class is pair, and then we take a graph equal to new array list and make. Okay, and after that we have to just take for loop, for int I equal to 0 and I less than equal to n and I plus plus. Okay, after that we just create a graph and dot add new pair, and this in this new pair what we have to do, we have to just 0 comma v comma weight. Okay, what do you mean by this? This is the mean by, it means what you are going to create, It means you just create a pair. First you create a pair of with 0 comma with common 0 with all the vertex, okay, and then we add this in the our list, okay. So we are adding this in our list. So first we are going to find out. So now so initially we have to just create a, I think we have to just create a all all vertices array list, okay. So now we have to just create the array list of all vertices. So now we are going to create the all vertices list, okay. So this is our all vertex list, and after that we are going to create a for int I equal to 0 and I edges dot length and I plus plus, okay. So after that what we are going to do, first what we are going to do, we are going to create the weight. We are going to create the uh, graph. So how we can create the graph? First we find u. How we can find? Just go on edges I dot u. We just find u because we store the pairs in this edge now, and then we just go int and v and edges I dot v, and then we just go and find weight equal to edges I dot weight. Then we just go and to graph dot add graph dot get at u position, add 0 vertex, add 0 vertex list and add new pair with common 0 with, because 0 is connected with everyone, because 0 with connected with everyone, 0 comma v comma weight, okay. Because 0 is connected with every time, because the 0 is connected with every time. And after that what we have to do, we have to go and create a graph dot get v dot add, okay, dot add a new pair with 0 comma u comma weight, okay. So we create the all pairs and graph, okay, all the pairs, and we created all the wedges, okay. So what I'm doing here is, like, if we have 0, then we created first we create the all edges, okay, like 0 to 1, 0 to 2, 0 to 1, 0 to 2, 0 to 3, 0 to 4, from that part, okay, from that part. And from that part what we are going to do, we create 1 2 1 3 sorry 1 2 2 3 3 5 all edges, okay, and weight all edges and weight. Now we are what we are going to do, we create a graph, and we are what we're going to do, we connect the two with zeros. We connect these all zeros with respect to weight, okay. Sometime we create the 0 to 0 to 1, sometimes create it with 0 to 0 to 2. It means that g2 connected with 0 with some weight, okay. Weight is provided here, weight is provided here, weight is provided here, okay. I hope you understand what I'm going to say you. After that what we're going to do, so we created a graph, okay. After that, after creating a graph, what we have to do, we have to find our answer, okay. So we just create an answer. After that we create a priority queue. After that we create a priority queue. After that we create a priority queue because we have to apply a Prim's algorithm. What is the Prim's algorithm? In the Prim's algorithm we just take a priority queue and add its neighbors, add the node's neighbors, and we just find out the which node is minimum. After that we find out the edge is the remaining edge is minimum, and when we connect the all with the minimum dots, then it will connect again and again in the forward minimum, okay. Priority queue. After that what we're going to do, we have to going to do pq dot add new pair 0 comma 0 comma 0, and then what we're going to do, we are going to do add the pq dot add. Okay, after that we have to just go and put a boolean. Okay, boolean visited and boolean visited equal to new boolean. Okay, why we create a boolean? Because it tells that how many vertex is visited. Okay, how many nodes is visited, how many edge is visited. Okay, and then put a while loop where what we are going to do, where we are going to do, where we have to put pq dot size greater than 0 or not. Okay, if pq dot size is greater than 0, then what we are going to do, we have to just find out what is our pair. Okay, we have just found out pair remainder equal to pq dot remove. Okay, pq dot remove. Okay, after that pq dot remove, if our remove is again is already visited, it already visited, then what we have to going to do is we just continue at this stage. We have to just continue continue. Okay, if this is not visited, then we have to just put visited rem equal to true. Okay, and when this visited equal to 2, then after that what we're going to do, we have to going to do find out that answer. Okay, sorry, how we can increase the answer plus equal to answer answer remaining dot weight. Okay, and then we have to just create a array list of pair nbrs equal to graph dot get remember dot vertical. Okay, after that what we're going to do, we have to going to do just find out what is our pairs. Okay, we just find out the neighbors array list. Okay, and then we have to go to find the all pairs in this neighbors. Okay, so what we're going to do, we have to just find out pairs. Okay, so what pairs? So pairs is like nbr in nbrs. Okay, so we just find out our pairs. If visited nbr dot vertex equal to false, then what we are going to do is you can say that if this is all neighbors is false, like if neighbor is not visited, then we have to add all neighbors. Okay, then we have to add all neighbors, and nbr dot vertex comma nbr dot weight. Okay, after that what we're going to do, we have to just return answer. Okay, so this is our result. Okay, so what we are going to do here is, again we have to just rewrite what I am doing here. So here we just go, sorry, we have to just start with first. Okay, so now you have to start with that part. Okay, so here we just find out our we just store our pairs like this in our graph. This is our connections. Okay, this is our connections. So we have a weight 5, 8, 3, 4, 9 and 7, and vertex is given by 0, 1, 3, 2, 4, 5, 6, 7, 8. This is given by this pipes. Okay, so this is our u, this is our b, this is our u, this is our this is our b, and this is our weight. This is our weight. So we just find out the all u and v and weight from this pipes which is given, and also wealth is given. Okay, and then we just find out the edges. We just find out the edges. And how we can find out the edges? We just create a pair. We just create a pair of this 0 to 4 to 3 weights. Okay, and then we just store in edge array. Okay, and after that we have commonwealth commonwealth with all nodes. Okay, and the weight of these whales is stored in here. Okay, so we just find out the weight, and we connected this with this pair. Okay, so how we can connect this pair? We just go and we create a pair with 0 to 3, 0 to 1, 0 to 2, 0 to 0. So all pairs is connected. It's making by that part. Okay, so after that, what we are going to do, we just create a array list of the graphs. Array list of the graph. We create a graph with array list, and the class is pair. Okay, and after that, we store the all edges. We find out the all edges and weight. Okay, and we create a graph. We create a graph, and then we apply a BFS. Then we apply a Prim's algorithm. How we can apply a Prim's algorithm? We just store the initial address, and then we take a visited, and then we remove the pairs, and we check out that if pair is visited or not. If it is visited, then we continue. If it's not visited, then we find out the weight of this visited, and we store in the answer. And we place visited. We mark the visited at line number 98, and then we create a array list of pair. We find out find out the all edges at this place. What I'm saying to you, we find out the all edges at this place. Like at 1, we find out 1 to 1 3. So we find out the list of 1 comma 3 with weight, 1 comma 2 with weights. Okay, so at this place we find out that part. Okay, and then we find out our neighbors like 3, like 2. Okay, and then we find out 3 neighbors. We find out the neighbors of 3, sorry, find out the neighbors of 4. Here are 4, this is 4, this is 2. So we find out the neighbor of 4. So we check out this, the neighbor of 4 is visited or not, like 2. If it is visited, then it will add in the pair class. Okay, and after that we return the answer. Okay, so now we are going to explain. So now we are going to execute this program. I think we got some error. Please check out the error. Oh, sorry. We are going to check out the error. So we are going to find out the errors. 1 second. We just run it here. $67. Right. So sorry. Here, remember dot vertex. I think here remember dot vertex. And now walls 67. At 67 wells over there. Wells. Okay. Then edge is there should be edge. Okay. Then oh sorry, the pipes line, the length will be pipe line with plus n. Okay, why? Because we are going to execute the zeros now, because when the zero is connected with another all the lines, then extra n will create it. Okay, so now we have to run it. Accept it, submit it. So this is answer. I hope you understand what I'm going to say you. Thank you.